good morning, good afternoon and good evening, whatever time you are watching this video. Today we are going to start the topic modulus. In the complex number, the next topic we are going to see is the modulus. It's a very simple concept. For the modulus, we have a notation like this. We have this as the notation for the modulus. This modulus is also called as the absolute value. Now here in this topic, we are going to talk about the modulus of a complex number, right? So suppose if our complex number is z, right, and this z is a plus bi. This is a complex number, right, where a and b are the real number. A is the real part, b is the imaginary part. This is your complex number. Z is the complex number. Now this complex number, if we are calculating the modulus or the absolute value, then what do we do is this z we can put it under this two, within the two vertical line, and we will read this as absolute value of complex number, that is z. And then we can calculate the process of calculating the absolute value is very simple. Sum of the square root of the sum of the square of the real part and the imaginary part. Square root of sum of the square of the real part and the imaginary part. A is the real part, B is the imaginary part. So sum of square root of sum of their square, sum of the square of the real number and real part and imaginary part. This is how we calculate the modulus. Is it very clear? So this is a very simple concept. We will use this formula to find the modulus of any complex number. Now we are going to start with question number 1 of exercise 21C. You can see the question on the board. The question says, if minus 2 plus root over minus 3 times minus 3 plus 2 root over minus 3 is equal to a plus bi, then find the real values of a and b. Find the values of a and b, and then also find the modulus of a plus bi. Find the modulus of a plus bi. So we are going to begin this question. This question is negative 2 plus root over negative 3 times negative 3 plus 2 root over negative 3 is equal to a plus bi. This is the given statement, right? So solving this statement, we will be finding the value of a and b. So let us start solving. Left hand side we can solve it as this is, first of all, from this two number we will separate the number from the sign. So it becomes negative 2 plus root over 3, and then this minus we can write as root over minus 1. The product of these two will be again same, so we can write it as it is. And then negative 3 plus 2, this will become root over 3, and then I is equal to a plus bi. Now here this part can be denoted as I. So the value is, now next is negative 2 plus root over 3, this will turn into I, and then similarly next bracket negative 3 plus 2 root 3 I is equal to a plus bi. A plus bi. Now we are going to further multiply these two. So negative 2 into negative 3, positive 6. Negative 2 into this will become negative 4 root over 3 I. Then this into this will become negative 3 root over 3 I. And then this into this will become 2 root 3 into root 3 will become simply 3. I into I will become I square is equal to a plus bi. Right? Now we can collect the like term. This is 6. These two are like term. This and these are like term. So they can be added together. So this will, sum of these two will become 7 root over 3 minus 4 minus 3 is minus 7 root 3 I. And then this is 2 3s are 6. And then I square means, like it is minus 1. Minus 1 into 6 will become as minus 6. This is equal to a plus bi. Now this minus 6 and this plus 6 is cancelled. Finally we got the value as minus 7 root 3 I, right, which is equal to a plus bi. So this is the final value that we have calculated for a plus bi. Now we can equate the corresponding element and we can have the value of a and b. So here this is corresponding to this term, so we can have the value of b, but then there is nothing corresponding to a on the left hand side. Therefore, we can introduce 0, right? And that will give you the value of a. So a is equal to 0 and b is equal to minus 7 root 3. Clear? So therefore, we can say a is equal to 0 and b is equal to minus 7 root of 3. We got the value of a and b. Is it very clear? This is the value of a and b. Now, we are asked to calculate the modulus of a plus bi. We are asked to calculate the modulus of a plus bi. So we are now going to calculate the second part of this question. Now where a is 0, right? A is 0 plus bi, that means the other part of this is minus 7 root 3 minus 7 root 3, right? This is the modulus of a complex number. Now we are going to calculate. So this will be equal to root over 0 square, right, plus minus 7 root over 3 and then whole square. Is it okay? Now, so it will become finally minus 7, right? What we can do is minus also we can separate from the number. So minus 1 square and then we can say 7 root over 3 whole square and then root over it. Now you know, like this minus 1 square, this is disappeared, this is gone. Now we have minus 1 square. Minus 1 square means it will become positive. So this is just 1. 1 is multiplied by this number, so that means it will remain as it is. Now this part also, this square and square root will cancel each other. So finally our answer is 7 root of 3, and this is the value of our modulus of a plus bi. Clear? Okay, now we are moving on to question number 2. The question number 2 says, find the modulus of the given expression. Find the modulus of the given expression. So let us see how can we find the modulus of this given expression. So first of all, let us write down the expression. The expression is 1 minus I to the power negative 2, right? Then plus 1 plus I to the power negative 2. So this is our given expression. Now this expression we have to solve. We have to find the modulus of this given expression, right? Now in order to find the modulus of this given expression, first of all we need to simplify this, right? Because this is not in the appropriate form to find the modulus. So we are going to first of all simplify this. For simplifying, first of all, step 1 is we will make the power positive. It will then become as equal to 1 over 1 minus I to the power 2. Is it okay? You know, like exponential law that we have studied in class 9, if you bring this, if you bring the power, if you shift the portion of the exponential number, then the sign of the power will change. So this is becoming now positive. Likewise, other term also we can do the same thing. We will write this as 1 plus I to the power 2. Is this okay? This both became positive. Now we can see these two as the fractional number. Now first of all, to simplify this, we will combine these two. We will simplify the two fractional number and make it into 1. So therefore, we are going to simplify to make these two fractions into 1. We are finding the LCM of these two. This is as equal to 1 minus I square and then times 1 plus I square. You know, the LCM is calculated by directly multiplying the two terms. In that case, the numerator we can get by cross multiplication. So we are going to write the numerator, this into 1 plus I whole square plus this into this 1 minus I whole square, right? Now we are going to expand the numerator by applying the formula a plus b whole square, a plus b whole square formula. I don't need to explain you again and again what is the expansion of a plus b whole square. So according to the expansion, this will be a square means 1 square. 1 square is 1 plus 2 into I and then plus I square plus next one is 1 square means 1 minus 2I and then I square is I say square of second term, that is I square. So this is I square divided by 1 minus I square, I whole square as it is, and then 1 plus I whole square as it is. Clear? Now we can see here, this 2I and this minus 2I will be cancelled. Okay, sorry, this was also I square. Now you know now the remaining is 1 plus 1, that is equal to 2, is equal to 2. Now this is I square and this also is I square. That means this I square value will be equal to minus 1. This also is minus 1. So minus 1 and minus 1 is minus 2. The denominator we are not doing anything. We will just keep it as it is only. 1 minus I square and then 1 plus I square. Now you can see in the numerator it will become 0. So 0 divided by any number, the answer is equal to 0. Right? Now the given expression we have simplified and we got the value of this as equal to 0. That means what kind of complex number we have? Right? This implies the complex number we have is complex number value is equal to 0. The complex number value is equal to 0. That means the real part and the imaginary part, both the parts of this complex number will be equal to 0. Therefore the complex number is actually 0 plus 0i. So this type of complex number we have because the value of this is equal to 0. Now we have to find the modulus of this one. So when you find the modulus of this one is equal to, it will be square of sum of square of 0 and then sum of square of 0 square plus 0 square. Finally this will turn into 0. So this is the modulus of your given expression. Hope it is clear. Now I am taking you to question number 3. Question number 3, we have some 4 part of this question number 3. This question is to verify the given statement. Question is to verify the given statement. So out of these 4 questions, I am going to take some few questions to explain you how can we verify the given expressions, right? So let us start first of all with part 1. Question number 3, part 1, solution of part 1, right? The given complex number we have is equal to 6 plus 8i, right? This is the given expression. This is the given complex number. With this complex number, we have to verify the statement that mod of z is equal to mod of z bar, right? Mod of z is equal to mod of z bar. This is read as modulus of the complex number. Z is a complex number. Modulus of complex number is equal to the modulus of the conjugate of complex number. This z bar is read as conjugate of complex number. Clear? So we have to verify that the value of these two are same. So let us find it out. It's very simple. First of all, we are going to calculate the left hand side. This left hand side is equal to modulus of z, right? This is equal to modulus of z that we can calculate as 6 square plus 8 square, and this is equal to 6 square means 36 plus 8 square means 64, right? And then we can add it. The sum of these two numbers will come as equal to root over 100. This is 100, and 100 is a perfect square number, and its square root will be equal to 10. Now look here. Since we are calculating the absolute value, that is why we will have only one value of z. Is it okay? Now this is the value of your left hand side. If the statement is true, that means the value of right hand side also will come same as equal to 10. Are you getting it? So let us try to calculate the value of right hand side. Right hand side value is equal to modulus of the conjugate of the complex number, right? So first of all, let us have the conjugate number. The conjugate of this will be how much? 6 minus 8i. How do we write the conjugate number? We write the conjugate by changing the sign, right? So this is the conjugate of your given complex number. Now we have to find its modulus. So this will be equal to root over 6 square plus minus 8 square, right? Ultimately this also will come same because 6 square is 36 and then 8 minus 8 square is 64. This is equal to root over 100, right? And finally this is as equal to also 10. Therefore we can say, hence therefore LHS is equal to RHS. Is it very clear? So this is part 1 of your question number 3, right? Now let us see part 2 of this question number 3. Part 2 of this question number 3 says what? Minus of mod of z is less than or equal to real value of the complex number. Is it okay? Is less than or equal to the conjugate of complex number, conjugate of complex number. Is it okay? Now let us try to understand this question, then the question will be interesting for you. This question, what it says is, find the value of negative of modulus of z, right? And then find the value of modulus of the conjugate of z. And the value of these two, the value of real part of the complex number, value of real part of the complex number should lie in between the value of this part and the value of this part. So here what we will do is, we will calculate the value of this part, we will calculate the value of this part, and then we will cross check, we will check whether the value of the real part of the complex number, value of real part of the complex number, does it lie between the value of this and this or not? Is it okay? The value of real part of the complex number is 6. This is the real part of the complex number, which is equal to 6, right? According to this statement, the value of this part should come less than 6 and the value of this part should come more than 6. So let us check whether it is coming or not. Okay. So first of all, we are calculating negative of mod of z. Negative of mod of z. Now negative mod of z, and z is 6 plus 8i. 6 plus 8i. Now we are calculating, this is minus sign, and then the modulus of this 6 plus 8i is calculated as 6 square plus 8 square is equal to minus sign as it is. This will become root over 36 plus 64 is equal to minus root over 100 is equal to minus 10. This is the value of our minus of modulus of z. We got the value this much. Now we are going to calculate the value of modulus conjugate of complex number. Modulus of conjugate of complex number, which we have already calculated here in the previous part, no? On the right hand side, right? And its value was given equal to, calculated as equal to 10. So we are not going to waste our time calculating, because already we have calculated, so we can just place the value. This is equal to 10. Now we calculated the value of conjugate of mode of conjugate of z, and then negative of mode of z. And then we can see the values are here in front of you. One value, the left hand value is minus 10 and the right hand value is 10. And the value of the real part of this conjugate number, we can say, since the real part of the complex number z is equal to 6, and now you can compare this value, yes, it lies between these two values. So we can say minus of mode of z is less than or equal to real part of the complex number, and it is less than or equal to the conjugate of mode of conjugate of the complex number, and hence this is verified. Hope it is clear. Let's take one more part, that is Roman number 4 of question number 3. It says prove that this statement is true now, right? So we know that the value of z is how much? Z is, once again, is equal to 6 plus 8i. This is the complex number we have. With this we have to solve this statement, right? So let us calculate the value of left hand side. Left hand side is equal to z inverse, right? Z is 6 plus 8i, and then to the power minus 1. Here once again we can see the power is negative, so as a result we will make the power positive. So for this we will take it down, 1 over 6 plus 8i, right? This is 1 plus 6 plus 8i. Is it okay? Now here the imaginary part is in the denominator. If the complex number is in the denominator, not only the imaginary part, the complex number is in the denominator. So we need to rationalize it, because if the complex number is in the denominator, such numbers are called as irrational number. So we need to rationalize. So for rationalizing, we will multiply the numerator and the denominator by its conjugate. That is 6 minus 8i divided by 6 minus 8i, right? Now when we simplify, this will come as equal to 6 minus 8i in the numerator. Denominator will be denominator. Now this 6 plus 8i into 6 minus 8i can be taken as the difference of a square, can be seen as the factor of difference of a square. A plus b and a minus b. A plus b into a minus b can be written as a square minus b square. So we can write this as a square means 6 square minus b square, that is 8i square. Is it okay? Now numerator will become 6 minus 8i as it is. Denominator 6 square will become 36, and then minus sign. 8 square means 64, and I square means I square. And you know I square, it means it's equal to minus 1. This value, I square value will be equal to minus 1. So that minus and this minus will make it positive. So this is ultimately 6 minus 8i divided by 36 plus this will become 64. Finally, our answer of left hand side is coming as 6 minus 8i divided by 100. This becomes the value of our left hand side. Now, if this statement is true, then the value of right hand side also should become the same thing. So let us check. Right hand side is equal to conjugate of the complex number divided by mode of square of the mode of the complex number is equal to. Now, conjugate of complex number. Complex number is 6 plus 8i. That means the conjugate of this will become 6 minus 8i. Right? For our convenience, we can write the value of conjugate of this complex number here itself. This is 6 minus 8i. That means we are copying the value from this part here. Come to the denominator. Denominator is mode of z. We are calculating the absolute value or the modulus of the complex number. You already know how to find the modulus of the complex number. Is it okay? So this is 6 square plus 8 square and then root over. Right? And then finally we also have the square. So we can square it. Is equal to 6 minus 8i divided by, now this square and this square root will cancel each other. So we will be left only with the radicand part. So this will become 6 square is equal to 36 and 8 square is 64. Finally our answer is 6 minus 8i divided by 100. We can see here the value of left hand side and right hand side both are same. Therefore the statement is proved. We can write therefore LHS is equal to RHS. Clear? Thank you. Next question we are taking is question number 4. In question number 4, as you can see on the board, there are so many subparts, but then we are going to take some few examples. I am going to demonstrate to you with some few examples. Here we have two complex numbers, Z1 and Z2. The value of Z1 is 3 plus 4i and another complex number Z2 is equal to 8 minus 15i. So with the help of these two complex numbers, there are some statements given. We need to prove that the given statements are true. Clear? So let us begin this question. First of all, let us have the two complex number. The first complex number we have is Z1, which is equal to 3 plus 4i. Another complex number Z2, which is equal to 8 minus 15i. Right? Now, first question is Roman number 1, where we have to prove that the mode of Z1, negative Z1, mode of negative Z1 is equal to mode of Z1. Right? This is the question. So let us prove this statement. Now we will calculate the value of left hand side. Left hand side is equal to mode of negative Z1. Now negative and Z1 is 3 plus 4i. So we can have 3 plus 4i. And then when we open the bracket inside, the signs will change. So it will become negative 3, negative 4i. And now we can find its modulus, which will be equal to square root of negative 3 square plus negative 4 square. This is then equal to root over negative 3 square will be equal to 9 plus negative 4 square will be equal to 16. 9 plus 16 will be equal to 25, and then square root of 25 is equal to 5. So the modulus of negative Z1 is equal to 5. Now find the value of right hand side, which is mode of Z1. This is equal to Z1 is 3 plus 4i, and then when we find the mode of this one, it will be equal to 3 square plus 4 square. This is equal to 9 plus 16. This is equal to root over 25, and then square root of 25 is once again 5, and therefore we can see that the value of left hand side and right hand side is equal. Therefore the given statement is proved true. So we can say LHS is equal to RHS. Clear? Now we will take Roman number 2 of question number 4. The statement is prove that the mode of square of Z1 is equal to square of the mode of Z1, square of the mode of Z1. Clear? So let us once again find the value of left hand side and right hand side. LHS we can calculate. This is mode of Z1 square. Z1 is 3 plus 4i, and then the square of it. Clear? Now let us simplify first of all the bracket. Mode of 3 plus 4i whole square. We can apply a plus b whole square formula. So it will be 3 square means 9 plus 2ab, that is 4 3 is 12, 2 is 24. 24i, and then square of the second term, that is 4i square, means it will become 16i square. Now when we simplify, this is 9 as it is, and then this is 24i, and then I square here is equal to minus 1. That means minus 1 into 16 will become negative 16. So finally our complex number is coming as equal to mode of 9 minus 16 will become minus 7 plus 24i. Now we have to find the modulus of this one, right? So this is equal to, now we can write this as root over, modulus will be written as negative 7 square plus 24 square square root. Now negative 7 square will be equal to 49, and the square of 24 is 576. When we add these two, it is coming as equal to 625, and the square root of this number is equal to 25. That means the value of our left hand side is equal to 25. Now let us calculate the value of right hand side. Right hand side is equal to square of the mode of Z1. Square of the mode of Z1. That means mode of Z1 is written as 3 plus 4i, and then square of this. Let us first of all find the mode of 3 plus 4i, which will be written as 3 square plus 4 square. Right? This is the mode of 3 plus 4i. Further we have this square sign, so we can write this as further square. Now simplify. This 3 square will be equal to 9, 4 square will be equal to 16, and then we have whole square. Now when we open, this square and square root will cancel each other. 16 plus 9 will become equal to 25, and this is how we calculated the value of right hand side also. Now you can see here the left hand side is 25 and the value of right hand side also is 25. Therefore we can say that the given statement is proved, and therefore we can say LHS is equal to RHS. Hope this is clear in question number 1. Now next we are moving on to, we are taking one more example, and that is Roman number 4. The mode of Z1 over Z2 is equal to mode of Z1 divided by mode of Z2. This is actually based on property of the complex number. So we will prove that the two values are same. Let us start again from the left hand side. LHS. LHS is equal to mode of Z1 divided by Z2. Now we can write this as 3 plus 4i divided by 8 minus 15i. This is your left hand side. Now as we can see here, the complex number is in the denominator, and as I told you in the previous question, if the complex number lies in the denominator, then it needs to be rationalized, right? And only then we can find out the absolute value. So we are first of all going to rationalize, because the denominator is having the complex number. So we are rationalizing it. So for rationalizing, 3 plus 4i divided by 8 minus 15i. That means the numerator and the denominator of this fraction is going to be multiplied by the conjugate of the denominator. This is the process of rationalization. So we will multiply this as 8 plus 15i divided by 8 plus 15i. Right? Now, numerator we can multiply. When we multiply the numerator, we are getting the result as 3 into 8, these two are multiplied, right? We can put this in a bracket. It will be more easy for us to understand. Now we can multiply. So 3 8 are 24. 24. And then 3 5, 15 3 is 45i. 45i. Now with 4i. 4i into 8 is 32i. And then 4i into 15i will become 15 4 is 60. I into I square. Now come to the denominator. Denominator is a minus b into a plus b. We can use the difference of a square. We can write this as 8 square minus 15i square. 15i square. And then mod. Now mod. Now this 24 and now this 60 I square. I square is, you know, it is minus 1. So when you multiply this 60 by I square with minus 1, it will become minus 60. So this is minus 60 and this is positive 24. That means these two are like terms, so they can be simplified together. So the result will come minus 36, right? And then 45i and 32i, they are like terms, so they will be simplified together. It will become 77i. This is the numerator. Denominator, we are coming down. Now this is 8 square means it will become 64. And then minus sign, and this is 15i means 225i square. 225i square, right? Now this I square is negative 1, right? So this is 225i square, and I square is because minus 1. That means it will make it minus 225. And that minus 225 with this minus sign, it will become plus 225. So this is plus 225. Finally, we are adding these two, and this will become 289. Clear? This is mod of. This is 289. Now we are going to do the redistribution of the denominator. So finally, our complex number will become minus 36 divided by 289 plus 77i divided by 225. 289. Right? First of all, we are just rationalizing, okay? We are only rationalizing. After rationalizing, now we are going to start finding the mode of this. After rationalizing, when we find the mode of this one, then it will come as equal to mode. Now we are calculating the mode from here. It will become, this is the real part, this is the value of A, and this is the value of your B. So it will become negative 36 over 289 square A square, that is then B square, that is 77 over 289 square. Please be mindful, we are calculating the mode of the given complex number. Is it okay? Now, this 36 square, when we calculate, we will get this as equal to 1296, positive 1296, right? And then this is 289. Both the numbers have the same denominator, right? So we will keep this common denominator. In the same step, we are going to make these two fractions into 1 also. Now the square of 77 will be equal to 5929. 5929. 5929. And denominator, we are just keeping it as equal to 289 square. 289 square. Is it okay? Now when we add the two numerator, we are getting the answer as equal to 7225 divided by 2. Oh, sorry. Since we are calculating the mode, sorry, absolute value, that is mode. So we will also have the square root sign. I'm very sorry. This is also square root sign. This mode will disappear. This mode sign, once we are calculating the absolute value, there will be no mode sign. Is it okay? So this is the square root of this number. Now, when this is 289 whole, this is square is equal to this. Now we are calculating the square root. 7225 is a square number, so we can have the square root of this number. This will come as equal to 85. The square root of 7225 is 85, right? And this is then 289, because here in the denominator the square and the square root will cancel, so it will become 289. Further, this can be simplified, right? So 17 5 is 85 and 17 17 is 289. So finally our answer of this part is coming as equal to 5 over 17. This is the value of our left hand side. Clear? This is the value of our left hand side. Now further we are going to calculate the value of right hand side. Right hand side. Let us hope and pray that we get the value of right hand side also same as 5 over 17. Only then we can see that the statement is verified. Now we are calculating Z1. mod of z1, that is mod of 3 plus 4i divided by mod of z2, that is mod of 8 minus 15i. Now when we are calculating the mod, it will become 3 square plus 4 square root over it. Denominator we will have 8 square plus negative 15 square and then root over. This is how we are calculating the absolute value. So in the numerator we will get this as 3 square means 9, 4 square means 16, root over, and then in the denominator we will have 8 is 64, and then 15 square is 225 root over this. Now finally in the numerator we are getting this as 25, and the denominator we are getting this root over 289. Fortunately, numerator and denominator both are the perfect square number, so we can write down the square root of this number. This will be as 5 square root of 25 is 5 and the square root of 289 is 17, and this is how we can see that the value of right hand side and the value of left hand side both have come same, and therefore we can say that the given statement is proved true, and we can say that therefore LHS is equal to RHS. So this is all about question number 4, and then remaining question of question number 4 can be taken as assignment. Thank you. Now we are taking question number 5, Roman number 4. This is the given expression, and then we have to use the appropriate property and we have to solve it. We have to find the modulus of this given question by using appropriate property. Is it okay? Find the modulus of the given using the appropriate property. So for this question, the property that we are going to use will be somehow like this. We can use the property, the mode of this will be equal to the mode of 2 minus 3i times 4 plus 5i divided by mode of 1 minus 4i times 2 minus I. So using this property we have to find the value. Is it okay? So means we have to prove the property as well as we have to find the value of this. Is it okay? So basically we have to find the value of this part. Is it okay? We have to find the value of this. We have to find the absolute value of this given. Is it okay? Now to find the value of this, to find the modulus or the absolute value of this given complex number, we are asked to use the property. We are asked to use the property. So we are going to use this property. Is it okay? We are going to use this property. Means either we can solve this one and then find the value directly, or we can use the property and also we can find out the value of this one. So for solving this, either you can directly solve this one, right? We can solve it directly. But when you are solving it directly, it will be little lengthy, right? And there we have to use the property of the modulus number, the complex number. So when you use the property of the complex number, then the simplification of this part will become very simple, very easy. So I will show you that how can we find out actually the value of this. If you want to calculate the modulus of this given complex number, it is going to be quite lengthy and the numbers will be very heavy. Is it okay? Because we will multiply these two, we will multiply these two, then we will get a new set of complex number for the numerator, we will get a new set of complex number for the denominator, and the magnitude of those numbers will become, the value of real numbers will become very big for this question if you do it by simplification. Is it okay? It is doable, it is not impossible, but when we use the property of the complex number, then that same complicated question becomes very easy. So let us see how do we do this question, okay? Using the property. So we will have the modulus of this one. This is 2 square plus negative 3 square. This is how we will calculate the modulus of our 2 minus 3i. Likewise, another one is modulus of this 4 plus 5i is 4 square plus 5 square. Denominator 1 root over 1 square plus minus 4 square. And then root over 2 square plus minus 1, 2 square plus 1 minus 1 square. Is it okay? Now, as a result, in the numerator we will have the square of 2 as equal to 4, the square of minus 3 will be as 9. root over, then we will have the square of 4 square means 16, and the square of 25 is 5 is 25. Denominator, we will come 1 square means 1, plus minus 4 square is 16, and then root over 2 square means 4, and then plus 1, right? This is further equal to root over 13, and this will become root over 41 divided by. Now likewise we will calculate. This is root over 17, and then this is root over 5. Is it okay? Now as a result, now when we are calculating this, we can get the solution as, we will multiply this 41 by 13. If you multiply 41 by 13, is coming as equal to 533. Because both are having the same radical sign, so we can have a common radical sign, and the radicands can be multiplied. Similarly, in the denominator also, we will have 7 5s are 85, and root over 85. Is it okay? And this is the answer of your given complex number. So we can, because we are having the same radical sign in the numerator and denominator, we can give a common radical sign, and we write the final answer as 533 divided by 85. Now none of the number is I square number, so this remains as the answer, and this is the value of your given complex number. So using the property, we could simplify this within no time, but if we don't use the property and simplify this complex number, it is going to be very lengthy. Is it okay? So with this, we are ending this exercise 21C. The rest of the questions you will take it as assignment. Thank you.